let's talk about mid-segments of triangles. This is the asynchronous recording for the third week of Geometry 1A. So again, Unit 3, Week 3. We're going to talk about mid-segments of triangles, specifically relationships within triangles, and the triangle mid-segment theorem. So the triangle mid-segment theorem tells me that if a segment joins the midpoints of two sides of a triangle, then that segment is parallel to the third side of the triangle, and it measures half of its length. So let's break that down into a little bit more detail and make sure we understand the fine points of what this theorem is telling us. So again, if a segment joins the midpoints of two sides of a triangle. So if you look at the diagram, the segment in question that we're talking about, and you can see it's even labeled as midsegment, is this guy right here. And you can see that its measure is x. Now, I know that that is a midsegment because it is formed, it says if a segment joins the midpoints, this midsegment is formed by joining midpoints of two sides of a triangle. And here's what I mean. This is a midpoint, this point is a midpoint for this side of the triangle. And I can see that again not only because of this marking here, but also because they've marked these line segments as congruent. So if a point splits a line segment into two congruent pieces, then it is a midpoint for that line segment. Same thing on the other side here. I can see that this point splits this side of the triangle into two congruent segments, so it must be a midpoint. So I've got two midpoints on two sides of the triangle, just like it said in the theorem. And I've got the segment that joins these two midpoints. So the conclusion is that this segment must be parallel to the third side of the triangle. And I think that intuitively your eyes understand that those two lines are parallel, but it is part of the theorem. So the segment is parallel to the third side of the triangle, and it is half of its length. So that's a little less intuitive, but it's just something we need to remember. So if I've got a mid-segment, then it measures half of the length of the third side of the triangle, the side that it is parallel to. Okay, so if I were to measure this, the measure you can see was labeled x. If I were to measure this side of the triangle, you can see that the measure is 2x. And to that end, let's do a little bit of practice calculating lengths or midsegments of triangles. So let's say we're given a triangle, we're told that this is the midsegment, and we're asked to find the length of the midsegment. Well, if I know that the length of this side of the triangle, and notice that this is the side of the triangle that this midsegment is parallel to, right? It's the third side of the triangle. Then I know that the measure of this midsegment is half of the measure of this base, right? According to that triangle midsegment theorem. So I know that my midsegment is going to be half of the base, or half of 46. So quick mental math tells me that half of 46 is 23. So I know that the length of my midsegment is 23 units. Let's look at another one. So in this case, I'm given a triangle, I'm given this midsegment, and I'm told that the measure of this midsegment is 46 units. And I'm asked to find the length of the base. And when we're talking about triangles, specifically in relation to midsegments and bases, when I say base, I mean the base as related to the midsegment, okay? So, for example, if I know that this is the midpoint of that side of the triangle. Let's say that this is a midpoint as well. If I had a line segment here, this would be just a different midsegment. There are three in each triangle, so this is a midsegment. And if I wanted to talk about the base that corresponds to this midsegment, it would actually be this side of the triangle, right? Because this is the third side. It's the side that this segment is parallel to, okay? So careful with what you think of as the base of the triangle. It doesn't necessarily mean bottom when we're talking about midsegments, okay? So anyway, if I know that my midsegment is a certain measure, then I know that it is equal to half the base, and I know that if I multiply the midsegment by 2, that would equal the base, okay? So if I take 46 and I multiply by 2, that tells me that the measure of the base is 92 units. So again, just converting from one to the other, I know if I want to go from midsegment to base, I multiply by 2. If I want to measure the base and figure out the midsegment, I divide by 2. Alright, let's move forward. So this time we're asked to find the length of the midsegment and the base. We're given each, but we're given it in terms of x. We're given it in terms of a variable. So how can I set up an equation so that I can solve x and then plug in x and get numerical answers for these line segments? Well, remember the relationships we were just talking about. So I know that my midsegment is equal to 1/2 of my base, right? So I can set this up appropriately. I can say, okay, well, I know that the measure of the midsegment is 5x minus 1. So that must be equal to 1/2 of the measure of the base, right? So this would be equal to m. This is b, my base. So I'm just plugging it into my equation that I've already established based off of the midsegment theorem. So, filling it in here, I can just simplify and solve for x. So I've got 5x minus 1 is equal to 1/2. In fact, let's just simplify here. So I know that half of 6x is equal to 3x. I know that half of 10 is equal to 5. If I subtract 3x from both sides of the equation, I can simplify. Let's see, what else can I do? I can add 1 to both sides of the equation. And finally, if I divide by 2 on both sides, I find that x equals 3. But I'm not done yet. They didn't say solve for x. They said find the lengths of the midsegment and the base. So I need to plug in x and solve for these sides. So if x is equal to 3, 5 times 3 is 15, minus 1 is 14. So the length of the midsegment is 14. If I plug in 3 for x, 6 times 3 is 18, plus 10 is 28. So the base measures 28. So notice I solved this through algebra, but I can check and see if these answers are reasonable because I can think about the midsegment theorem. So I got the answers 14 for the midsegment and 28 for the base. This is reasonable because it agrees with the triangle midsegment theorem, which tells me that that midsegment should be half of the base. So since 14 is half of 28, there's a good chance that I have solved this correctly. All right, let's keep going. So here we just have another variation on using the triangle midsegment theorem to find measures of different pieces of the triangle. Okay. So I'm told that I've got these midpoints H, J, and K. And I'm asked to find a few different line segments. Now remember, when we're looking at triangles, it is important that they tell us this information so that we know whether or not we can apply the triangle midsegment theorem. Okay, so for example, if I was just given a triangle that looked like that one, and it had some measures on it, but it didn't tell me anything about the relationships between any of the points or anything like that, I couldn't really press forward because I wouldn't know if it'd be appropriate to apply the triangle midsegment theorem. However, they've told me that these are midpoints. So if H is a midpoint of E and F, so I know these two sides are congruent, right? If H is a midpoint, and if J is a midpoint for these two pieces here, then I know that the segment formed between them is a midsegment. And I could say the same thing, HJ forms a midsegment, but so does HK and so does JK, right? So let's see if I can use this information to figure out the missing pieces here. So first they have asked for HJ. All right, so again, I said that HJ must be a midsegment based on the explanation I just gave. So that means it is parallel to line segment EG and also half of its length. So if EG measures 100, half of 100 is 50, so HJ must measure 50. Let's look at the next example. I'm asked to find JK. All right, so JK is here. So again, by the midsegment theory, I've already figured out that this is a midsegment, which means it's parallel to EF and half of its length. So if EF measures 60, JK must measure 30. Finally, I'm asked to find the measure of FG. So I know that HK is a midsegment for this triangle. I know that it must be parallel to FG, and I know that it is half of its measure. So if HK measures 40, then FG is twice as long. It measures 80. All right? Let's look at another one. Okay. So here's another one. Again, notice that as we do this, in each of these examples, we are practicing applying the triangle midsegment theorem, but we're having to call on different definitions and our different knowledges of geometry to really solve the problem. So here's just another application of it. In this case, once again, we're given a triangle. You can see the measures that are in place. We know that M, N, and P are midpoints. So we know that each of the segments formed between each of the midpoints must be midsegments, right? And we're told that the perimeter of this triangle, M and P, is 60. Okay? And the first thing they ask us to do is to figure out the measure of NP. So hopefully your brain automatically went to thinking, okay, if I know that the perimeter of that yellow triangle is 60, then I know that it's 3 sides. If I add the measure of the 3 sides together, those must equal 60. And this is going to allow me to solve for the length of segment NP, right? So just solving here, simplifying, let's see, 22 plus 24 is 46. And subtracting 46 from both sides, I find that x equals 14. So NP is equal to 14. That's done. Our next task is to find YZ, which is right here. YZ. All right, so once again, I know that NP is a midsegment, and I know that it must be parallel to YZ and half of its measure. So YZ must be 48. One thing I do want to point out, students can sometimes, because it is kind of an easy calculation, just keep track of whether you're taking half of something or whether you're doubling it, okay? It'd be really easy to make the mistake and think, oh, 24, half of 24 is 12, and claim that YZ measures 12. Again, just something to keep straight. Make sure you don't rush through problems and make simple mistakes like that. We're going to look at one final example. So once again, we're given a triangle. Segment AB equals 10, segment CD equals 18, and we're asked to find EB, BC, and AC. So let's take a look. Well, let's label what we know. So we know that AB is equal to 10, and we know that CD is equal to 18. So the first thing we're asked is to find EB. All right, well, once again, notice, so here's my segment EB. Notice that the segments, so I've got this point E that's separating our segments, and so I've got a segment ED and a segment EA. Notice that they're congruent. So if segment ED is congruent to segment EA, they have equal measure, and E must be the midpoint. So I've got a midpoint. Same thing on the other side. If I take a look at B, and I look at the segment AB and the segment BC, I see that they're congruent to one another. And if they're congruent and then they have the same measure, then B must be a midpoint of these two line segments, or of the segment AC. So if B is a midpoint of AC and E is a midpoint of AD, then together these two midpoints form a mid-segment of triangle ACD. Okay, now I know that's kind of a long-winded explanation, and you can kind of determine this just by looking at it, but I think it's important to be able to explain why you can claim that this is a mid-segment. Again, remember, if things aren't labeled on the triangle, don't just assume any old triangle with a line through it. Don't automatically assume that that's a mid-segment, okay? So if EB is a mid-segment of this triangle, then EB must be parallel to DC and half of its measure. And I know that DC measures 18. Half of that is 9. Next I have BC. BC is this line segment here. Well, based on those markings, I know that BC must be congruent to line segment AC because both of them have those 2 tick marks, and that's telling me that anything with 2 tick marks through it is congruent and has the same measure. So BC must also measure 10. Finally, they want to know the measure of line segment AC. Well, if AB is 10 and BC is 10, sorry, you can't really, it's hard to see, but if AB, the first part, is 10 and BC is 10, if I add those together, then my line segment is equal to 20. Okay? So again, keep track of the triangle midsegment theorem. Remember that you may be asked to call on other definitions, other theorems, other ideas to kind of inform and be able to answer these problems. If you want credit for watching this video, please go check out my Google Forms asynchronous quiz, and I will see you guys next week.